Okay. So at the beginning of this unit, we talked about how to calculate confidence intervals for one proportion. So like if we wanted to know what percent prefer this brand of product, or what percent prefer this candidate in an upcoming election, questions like that. We would find a percentage based on our sample proportion, but then we would have a margin of error, that it could be higher than what we found, could be a little lower than what we found. Sometimes we are interested in finding a difference between two proportions, like say the difference between men and women, the difference between cultural groups, the difference between two brands of a certain product. Okay, so we can calculate confidence intervals for a difference between two proportions. And this example that we're going to use was very similar to one that we used previously, okay, where we had a male and female resume, but this time we have, you can see here, resume of a commonly white name and a resume of a commonly black name, and they were sent to job placement ads in Chicago and Boston. They were randomly assigned either a commonly white or commonly black name. And out of the results, okay, because they sent 2,445 white names, 2,445 black names, they received callbacks on 246 out of the 2,445 white names, but only 164 out of the 2,445 commonly black names. Okay, so really what we're trying to get from this question was, is there any kind of discrimination going on? All right. So because we're dealing with two samples, really, okay, we're going to talk about two sample inference. We've already talked about one sample inference. So here we have a table that shows the results of what was just summarized above, okay, where P hat 1 represents the proportion of commonly white names that got callbacks, and P hat 2 represents the proportion of commonly black name applications that got callbacks. So we want to calculate the following. Sample size for the first group, sample size for the second group, sample proportion for the first group, sample proportion for the second group, and the difference between the two. Okay, so remember, the 1 represents the white name group, and 2 represents the black name group. So for N1, well, the sample size for N1 and N2 are the same, 2445. Okay. The sample proportion, white names that received callbacks, 246 out of 2445. You can leave it as a fraction, or you could approximate it as a decimal, which would be 0.101, slightly over 10%. Portion of black names that received a callback, 164 out of 2445. Again, you could leave it as a fraction if you want, or change it to an approximate decimal, you would get 0.067. So a little over 6.5%. Yes, very good. And obviously the difference between the first sample proportion and the second sample proportion, we could either subtract the fractions or subtract the decimals. So we get 0.101 minus 0.067. and we would get approximately 0.034. 34? So that suggests that 3.4% more white names receive callbacks than black names. Is that different enough to show convincing evidence of discrimination? It seems to suggest it because there was a higher proportion in the sample of white names that received callbacks than there were in the black names. But could the difference just be chosen because of the samples we took? It's possible, right? We don't quite know for sure. So it requires further analysis, which is what we've been doing all along. Okay? So we would say something to the effect, it's difficult to say, because there seems to be discrimination, but further analysis is needed to see if this difference occurred by chance. Which is what we always seem to answer when we get a question like this. It seems like something's happening, but it also seems to be close enough that we can't say for sure. So let's analyze it further. According to how we did confidence intervals for one sample. So in a one sample situation, we compare a statistic in one population against a claim about that population, some proportion. But in a two sample situation, you measure the same statistic in two populations. Or treatments. Because really, this is like an experiment, this one that we're working, and see if they are significantly or statistically different. Okay, yeah.
What difference you would need to get to like know for sure that there is discrimination?
Well,
3.4% is too low.
so we would have to find a confidence interval, right, to find the difference. And then there's going to be a margin of error, right? If that margin of error does not take us below a difference of 0, we can say that there's discrimination. So like, let's say we got, it was, what did we get? 3.4% according to the sample. And let's say there was a margin of error of 4%. Well, that means if I go 3.4 minus 4, I'm down into negative, right? Which means that there was actually discrimination against white. Okay? So that means I can't say conclusively. However, if it was 3.4% and the margin of error was 2%, well, all the results are above 0, right? Which means there's a positive difference in callbacks for white names than black names, which suggests convincing evidence of discrimination. Okay. So just an example that's different from this, just so you can get an idea, a one sample, okay? Is the proportion of Brand A batteries that are defective greater than 5%. So those are like ones that we've been doing, and we did at the beginning of the unit. A two sample one though. Is the proportion of defective Brand A batteries greater than that of Brand B. Now we're looking at finding the difference. Because we've got two groups, and we're going to be finding two proportions in the difference between them. Okay, so if you recall, when we first did confidence intervals, we kind of did the long way, and then we did the graphing calculator way, which is a shorter way. So what we're going to do with this situation is, remember, because we use Z scores, or sorry, Z star for confidence intervals, which tells us how many standard deviations away we go from our point estimate. Okay, you have to wait. Sorry.
Okay.
Calculate and interpret a 95% confidence interval for the two difference in callback rates. So we can set it up as such. Remember when we did a single sample or one sample, it was just p hat. And then for the standard error, it was p hat times 1 minus p hat over n and take the square root. Well, now because we're dealing with two, okay? The point estimate is going to be the difference between the two. And the standard error, I'm going to do the sample proportion times 1 minus the sample proportion over the sample size of that group, plus the other group, and then take the square root, not minus, plus. Okay? Because remember, when we're talking about standard error or standard deviation, we're talking about total spread. So even though we're doing a difference, we add the spreads. Okay? Okay, so according to the results that we got, okay, the average of the difference in our sample proportions, or the mean of the difference in our sample proportions, will be the difference in the two samples we got. So it'll be what we got on the previous page of 0.034. That's our point estimate. The standard error of the difference between the two sample proportions, well, so in the first proportion, or the sample proportion was 0.101 times 1 minus 0.101. Divide that sample size of 2445. Plus, I'll have to put this down here. In the second one, the proportion was 0.067. So we have to times it by 1 minus 0.067 and divide by the divide that by the sample size of that group. Remember, that's still under the square root. Yeah, very good. Yeah. I can't believe people are still actually excited about it. So therefore, I got this is 0.034, and when we do this whole calculation, it works out to approximately 0.0079. Okay. Well, so our point estimate is 0.034. Remember, we're trying to find margin of error now. Okay. Our standard error was 0.0079. So I got to add that repeatedly to the right and subtract it from 0.034 repeatedly to the left. So I get 0.0419. Add again, and I get 0.0498. Add one more time, and I get 0.0577. Then start here and subtract 0.0079. 0.0261, 0.0182, 0.0103. It looks like actually I've answered the question just by looking at these numbers, because not one of them is negative, is it? So there's no negative difference. So just remember, this is when we do a distribution of all the sample differences. Okay. And because we want 95%, well, 95%, how many standard deviations is that away? Do you remember the number? It's 1.96 now. So we have to go 1.96, so just a little bit under there. So it's going to be somewhere here and just a little bit under there. So that's our 95. That's where 95% of our sample differences will occur. Okay. And how do we figure that out? Well, we'll go to the next page and calculate it up top. Find the 95% interval. Remember, you get this formula, the confidence interval is the point estimate, 0.034, plus minus the critical value, which is the standard deviation for 95% confidence, times what the standard error was.
No, 1.96.
Sorry, 1.96. Not sure why I wrote that. So when we do that, we get 0.018516 if we want to get precise, all the way to 0.049484. So these two would be the values here. So this would be, I'll just, as 0.0185. I won't write all the numbers. I'll just round it to 4 decimal places. 0.0495. Okay. So, answer 2 questions. Interpret the interval. Well, you guys should know how to do this. You just wrote a test, which is very similar. How would I start it? We are 95% confident. The interval, or that the interval. And then write the interval. Stands or captures the true of difference in callbacks, right? Good. And does it provide convincing evidence of, well, discrimination? Yes. Why?
Even the more it's there, it doesn't go below 0.
Or we could say the difference in the interval never goes below 0,
Or,
right?
yeah.
We do have convincing evidence of a higher callback rate for white names because the interval difference never goes below 0. What's below is just a summary of confidence intervals for a 1 sample and a 2 sample. 95% interval, we know to use 1.96, but 99 or 85 or 94 or 90 or whatever, okay? It's the same, except we have to calculate a different critical value. Okay? And we have to do that if we do it the long way by doing inverse. I know, stunning. Okay. So that's the long way. But we can avoid all those calculations and drawing a normal distribution by using a graphing calculator and using the 4-step process again. So let's see how much you remember. So nothing new here. Okay, this is all the information that was at the beginning of the lesson. We're asked to construct and interpret a 95% confidence interval. What's the first thing I'm going to do? State. What are we doing?
We are constructing a 95% confidence interval.
We are constructing a 95%, and I'll just put CI. For, and remember, we don't use the hats here. For P1 minus P2. And then we have to define each one. Where P1 equals true proportion of white names who got callbacks. And P2 equals true proportion black names who got callbacks. Okay. Plan.
We will,
Continue.
we will,
Do.
do once, and it's two sample Gazette interval
Good.
for P1 minus P2. If all conditions are met.
We will do a 2-sample Z interval. P1 minus P2. If, and then we can state the conditions. Okay. Random. What does it say in the question? Right. So they were randomly assigned a white name or a black name and then sent out. Okay. So random assignment of names. Do you remember this next one? 10%. Didn't we say this was an experiment? And when it's an experiment, we don't have to verify the 10% condition. So all we have to do is write experiment. Because all the resumes were randomly assigned to one of two groups. However, the large counts, we do have to do some calculations. And we have to do 4 calculations. 2 large counts for the white, 2 large counts for the black. So we have to do N1 P1 and see if that's greater than or equal to 10. Sorry, N1 P hat 1 greater than or equal to 10, and N1 1 minus P hat. And then we have to do the same for the second group. So we would get 2445 times the proportion of white names in the sample that got callbacks, which we said was approximately 0.101, which gives us about, I'm just going to round to the nearest whole number, 247. $24.45 times 1 minus 0.101 is going to give me about 2198, which is definitely greater than or equal to 10. For the second group, 2445 again times the sample proportion in the second group, which was approximately 0.067. And that will give us to the nearest whole number 164. And then 2445 times 1 minus 0.067 gives us approximately 2281. All of which are greater than or equal to 10. Which means I can go ahead. Okay. And now this time though, I'm going to go ahead with my graphing calculator. So remember, you find tests and intervals under stat and then scroll over to test. But this time it's not one prop Z int, it's two props Z int.
Why don't we do some math on that?
Pardon me?
Math on that.
Uh-huh.
Okay, sorry.
We've already done it. Oops. Oh, there we go. Yeah, not two prop Z test. Make sure you get the right one. So you see you've got 5 things to fill in now. Okay? You've got the number of white names that got a call back over the sample size. Then you've got the number of black names that got a call back over the sample size, and then a C level of 0.95. So we should be going, and this is under the do. So we're doing 2 prop Z int. And we've got X1 as, let me refresh my memory here, 246. N1 as 2445. X2 as 164. N2 also is 2445. In C level, 0.95. So 246, 2445, 164, 2445, 0.95. And you'll notice you get something very similar to what we got when we did the long one. And then, of course, we conclude, and I'm not going to repeat this whole thing again, but remember it starts with, we are 95% confident the interval. This captures the true proportion in the difference of callback rates between white and black names. Okay? And I'm not going to write all this over again. I'm just going to put same as previous conclusion. Because none of the proportions were negative, we have convincing evidence that there was a significant difference. And suggests that there is discrimination going on. Okay? Really, the big thing to remember here is in the plan under the large counts condition. That's what you have to watch out for. Whereas before we only had to calculate 2 counts. Now we have to calculate 4 counts because we have 2 groups.